All right, so it is hard to believe how tiny an atom is, yet an atom is made up of even smaller parts. They're what we're going to look at today, these even smaller parts. Since the invention of electron tunneling microscope, we can see atoms. So these are really, really big microscopes, like this big, and we only really get them at universities and in research labs because they're also really, really expensive, okay? Now, what we're able to do with these is it gives us the means that we know what atoms are going to look like. At the center of an atom is a dense, keyword for you that I'm going to highlight, nucleus. And a nucleus is composed of charged particles called protons. I'm going to use a different color now. You can use the same color though, it's fine. I just want to highlight all of our different words in different colors today. And protons are positively charged. The final thing found inside the nucleus are neutrons. And neutrons are neutral particles. Does anyone know what I mean by neutral? Yeah? Yeah, they have an even charge or they have no charge. So neutron, no charge. Now, the neutrons and the protons are almost the same size as one another. And because they're the same size, we can say that they have the same mass. So a proton has a mass of 1. And if we compare it to an equivalent neutron, the neutron has a relative mass of 1 also. So by relative, I mean they're pretty much the same. So from a chemistry perspective and from a year 9 perspective, we're going to say that neutrons and protons weigh 1. So if I had 1 proton and 1 neutron stuck together, what would be the total weight?
2.
What if I had 3 protons and 2 neutrons? What would be the total weight? 5. Okay. So around the neutron now, there are lots of areas of space, and this is where we have negatively charged particles. And then these negatively charged particles are called electrons. Okay. Now electrons are very, very, very small. They're smaller than protons. So it takes about 1,840 electrons to equal the mass of 1 proton. Okay. So with that, we generally say that the mass for electrons is 0 because the mass is so tiny that it doesn't really affect us too much. Question, then question.
If an atom is the smallest thing, then why is it an electron? If electron's smaller than an atom?
Great. Well, what we've actually discovered, so while the atom is the smallest thing that we look at, it is made up of these things called subatomic particles, which are protons, neutrons, and electrons. Now we've actually found something smaller as well, okay? All these things are made up of things known as quarks, okay? Do we need to know them? No, okay? So what we're going to focus on is the atom and the 3 main components of the atom, okay? Protons, neutrons, electrons. Next question. No, you just need to know 1, okay? It weighs 1. Was there another question? No? Excellent. So, electrons, okay, don't sit in one place at any given time. So, the easiest way I could relate these is we can see these electrons are the blue dots in the diagram, and they're floating around this central nucleus. We could almost liken it to our fan, okay? Our fan, the center of the fan would be the nucleus. And then what the electrons do is they spin. Now, if you were to look at any one fan blade as it's spinning now, could you follow that fan blade around? Yeah? What if we increased it so that it was really, really fast? Could you still follow it? No. And so what we end up with is not so much electrons in any one spot, but we end up with a cloud, okay? But from a year 9 perspective, we don't need to worry about the cloud. I just think it's a really interesting thing to talk about. What we need to worry about is instead, we need to worry about where the electron is most probably going to be, okay? And this area that it's most probably going to be is known as a shell. So these electrons like to live in their own shell. So, let's have a go now at just labeling this diagram. So something that I already mentioned was in blue, with the things going around the outside. So what are all these blue orbs going to be? Electrons. So let's draw nice straight lines out to the side. These blue dots are the electrons. Up next, I'm going to highlight it, and I'm going to use the same colour that I did up there. So I use yellow up here. Everything in this centre here. Now my highlighting is a little bit rough, it's gone over the edges. But everything in yellow is what we refer to as the what? Awesome. Okay. Oh, that's a little bit thick. Let's fix that. Nucleus. Within the nucleus now, there are two different types of things. Okay. Now, in this nucleus, what are the two different types of things that we can get? Protons and they each have a mass of, so what would be the total mass in this atom right now? 7, okay? And the reason that it is 7 is we have, I'm going to use red here because it's in red, we have 3 protons and we have 4 neutrons. So now we've labelled the protons, neutrons, electrons, and the nucleus, okay? We're going to talk a little bit about some of their features. So let's start with the location, okay? Where are protons found? What is the site? Awesome, they are found in the nucleus. What about neutrons? Where are they found? Nucleus. And lastly, the electrons. Good. They are found in a shell which circles or moves around the nucleus. Okay? So, number 1, I've done electrons in blue, so I'll do the same thing here. So, electrons, if we go back to our passage, we don't really know where they are at any given moment. However, we know where they're going to be roughly. And so, electrons are orbiting the nucleus. Okay? So, orbit the nucleus, full stop, found in shells. Found in shells, full stop. Now, I'm going to make these really big and really clear here. When we've done protons, I've done it in red. So what is the charge of a proton? We said it was positively charged. So I'm just going to write a big plus symbol here, like that. When we talk about neutrons, what is their charge? Neutral. And so if we have a neutral charge, I'm going to represent it as 0. Okay. When we talk about electrons, what was the charge for electrons? Negative. And so we have a negative symbol here. So, very careful. Protons. I always think of protons because protons have a positive charge. So I'm going to write it down here. The reason being they both start with P. The neutrons, I've always remembered what their charge is because they have a neutral charge. And again, starting with the first part, that NEU. Okay. Now when we talk about the mass, we say that protons and electrons both have a mass of 1. So we're going to write 1 in each of these boxes. But then we discovered that electrons have a mass that is 1,840 times smaller than that. So what can we say that it's roughly going to be equal to? 0. So we're just going to represent that as 0. So what I'm going to get you to do now, okay, I want you to have a go at question 3 for me. So use the diagram to answer the following questions, and then we'll go through the answers shortly.